So we are surrounded by matter. Matter is anything that occupies space and has mass. So your textbook, your cell phone, your body, the chair that you're sitting in, all of these things are matter. The air that we're breathing is also matter. It occupies space and has mass. Now there are things that are not matter. Energy, light, ideas, emotions. They may seem to occupy space in your brain, but they don't actually have any mass, and so they are not considered matter. So we'll talk a lot about matter in chemistry. A specific instance of matter is called a substance. So some things are compounds, and some things are elements, and some things are mixtures, and instead of trying to identify what that thing necessarily is and use all these different words, sometimes we'll just say a substance. So I could say that the liquid in my cup here, that is a substance. It's a specific instance of matter. And so that's a specific thing that we would be talking about. We can classify matter in several different ways. And we do this in everyday life as well, especially with young children. I mean, if you think about automobiles, motor vehicles, there are lots of different kinds of motor vehicles, right? You could classify them by the type of fuel. Well, this one runs on gas, these kind run on diesel, these are electric, and these are hybrid. And then there's the hydrogen ones. You could classify them by their color, by how many wheels they have, by what size they are, by how many doors, etc. So in science, when we look at classifying matter, there are also different types of categories that we use. Two very useful ones are the state and the composition. So the state would be the physical form, the composition is what is it composed of. So there are three primary states of matter. There are some other ones, but we're not going to talk about them in this class. So solid, liquid, and gas. We are familiar with water in all three of these states, so I'll use water as an example a lot. So if you take a solid such as ice and you heat it up, it will turn into a liquid, right? And if you take the liquid and you heat it up, it will turn into a gas. That's what happens when you boil water in the stove. If you let it boil long enough, the water starts to go away, there's not as much liquid left. What happened to it? Well, it went into the gas state and floated out into the room. So the state of matter changes with temperature. We have an illustration here of what the molecules or atoms might look like in these different states of matter. In a solid, the particles here are very close together, and they are also not moving relative to each other. In a liquid, the particles are still close together, but now they're just sort of milling about. And in the gas state, there's a lot of distance, separation between the individual particles, and they are moving around. So I like to use a lot of analogies. So I have an analogy for this. It's the three states of students, okay? So currently, you guys are in the solid state. You're sitting in chairs, and everybody's static, right? You're not moving relative to the people around you. I'll stand still so that I fall into that pattern. Now, that doesn't mean that you aren't moving, but you're not moving relative to other students. In lab, when we are going over to the balance and we're going to the hood and we're doing this and that, we are still in this same room. We're still close together, but now we're moving past each other. We're moving around. That's like a liquid, the liquid state of students. The gas state of students would be when class is over and everybody diffuses out the door and you go off and you go your separate ways. And now you're very spread apart from each other. So that's what the particles are doing in solids, liquids, and gases. So this is just more details with words. So in a solid, the particles are close together. They're in fixed locations. The particles will vibrate, they'll move, just like you guys are, fidgeting a little bit, and somebody's taking notes, and everybody's breathing, right? Breathing and maybe blinking, but you're not moving around. So solids have fixed volumes, their volumes don't change, and they have rigid shapes. You take a block of ice and you put it on the floor, it retains its shape. It doesn't happen when you pour water. Water will change its shape. So different kinds of solids, and we'll talk more about these later on in the semester: crystalline and amorphous. So in a crystalline solid, the particles have a definite arrangement. I'd say you guys are a crystalline solid right now because we're mostly in rows. Amorphous, A is a prefix that means without, and morph refers to shape, without shape, so no long-range order. This would be like kindergartners sitting around on the floor around the teacher at story time. No particular arrangement. They're just all kind of sitting on the floor together. Liquids, closely packed particles still, but moving relative to each other. So liquids have fixed volumes, but they do not have fixed shapes. They will take on the shape of whatever container they are in. In a gas, there's lots of space between the particles, and they're able to move. So gases are compressible. Their volume can change. If we put a solid or a liquid into a container like this and we put pressure on the piston, we cannot push these particles any closer together. They are already as close as they can be. If we have a gas, though, and we put pressure on this piston, we can squeeze those particles together because there's a lot of empty space between them. So gases are compressible, solids and liquids are not. So any questions about classification by state? We also classify matter by its composition. So here's the big idea in this flowchart right here. So here we have matter, and we can have two different categories here: a pure substance or a mixture. And then pure substances fall into two categories: element or compound. Mixtures fall into two groups: heterogeneous or homogeneous. So the difference between a pure substance and a mixture. A pure substance has only one component, and the composition is always the same. It doesn't change. So if you were able to zoom in and look at the individual particles that make up that substance, all the particles would be the same. There's not two or three different kinds of particles. All the particles are the same. In a mixture, you do have two or more kinds of particles. You have two or more different substances that are mixed together, a mixture, and the proportions can vary. So if you think about sweetening your tea, right? So you could put a teaspoon of sugar in your tea, or you could put 3 teaspoons of sugar in your tea. It's a mixture between the tea and the sugar. The composition can vary. So if we take the pure substance, only one kind of particle, we can divide this into two different types: elements and compounds. And the difference here is, can those particles be broken into simpler things? An element is a substance that cannot be chemically broken down into simpler substances. So these are the basic building blocks of matter. You can't take those Lego bricks and make them smaller, break them into simpler things. We have a single kind of particle. Helium gas is an example. Helium gas is just helium atoms. You can't break those atoms into anything more simple. In a compound, you have two or more different elements that are combined together. So water is an example of a compound. In pure water, all the particles are the same. It is a pure substance. They're all 1 oxygen, 2 hydrogens. But you can take those water molecules and break them down. In fact, you can do it quite easily with a 9-volt battery. Put a 9-volt battery in a glass of water and watch it for a little bit. You'll see little bubbles form at the terminals. One of them's hydrogen and one of them's oxygen gases that are forming. The electricity is breaking the water molecules into hydrogen and oxygen. And so water is a compound, not an element. It can be broken down into simpler substances. Compounds do have definite proportions, though. In water, even though it is a combination of oxygen and hydrogen, the proportion of oxygen to hydrogen is always the same because of the particles in those molecules are always the same. So then mixtures fall into two categories, heterogeneous and homogeneous. We use a lot of prefixes in science, and so it can be helpful to understand what those prefixes mean. A lot of these prefixes get used in everyday life as well. So hetero is a prefix that means different, and homo is a prefix that means the same. So homogeneous is the same throughout. Heterogeneous mixture has different parts to it. Okay? So the categorization there is how uniformly the substances mix. So in a heterogeneous mixture, it's different. The composition varies. There's lots and lots of examples of mixtures. One example would be a mixture of salt and sand. You mix salt and sand together. You can kind of imagine doing this, and it might look fairly uniform, but if you look closely at it, you don't even need a microscope. You can see, oh, that's a salt crystal, and that's a little grain of sand, and that's a salt crystal. You can see that there are different parts. Another example might be macaroni and cheese. So in the macaroni and cheese, you have the cheese sauce, and you have the macaroni pieces. And you can see that they are different, right? It's a heterogeneous mixture. In a homogeneous mixture, the components mix very thoroughly. It appears to be a single substance. So like if you look at the liquid in my cup here, under the ice cubes, this pink liquid. Anybody know what that is? It's Rockstar Zero Punched, is what that is. It looks like a single substance, but it's actually a homogeneous mixture. There's obviously some pink coloring in there, there's water in there, there's caffeine in there, and there's flavors and lots of different things, right? But it looks like it's one substance. It's a mixture. Okay? Yeah. Now, when we have a mixture, we can separate a mixture by taking advantage of differences in the physical or chemical properties of the components of that mixture. And there are lots of different techniques. I'm just going to talk about them very briefly. Some of these we'll do in lab, and others we will not. If you think about a mixture of sand and water, so imagine taking, say, a bucket of water from the tap and then putting a scoop of sand into it and stirring it up. Would that be heterogeneous or homogeneous? Heterogeneous. Because what's going to happen when you stop stirring? The sand sinks to the bottom, right? How could you separate the water from the sand? Well, you could let it settle, let the sand settle to the bottom, and then you could pour the water off the top carefully. You don't want to agitate the bucket and stir up the sand, but if you pour carefully, you could pour the water off the top, right? That's called decanting in chemistry. Pouring a liquid from the top of the container and leaving the solid behind. So that's one way to separate a mixture. Here you're taking advantage of the difference in state. One is a solid, one's a liquid. If you have a homogeneous mixture of two liquids, say of alcohol and water, you can't decant that because it's a homogeneous mixture, but you can distill it. So distillation takes advantage of the differences in boiling points of liquids in a mixture. So this is a very old-fashioned distillation setup. You've got a round bottom flask here with your mixture. Those liquids have different boiling points. We heat this mixture, and the substance with the lowest boiling point will vaporize sooner, and so it will go into the gas state. We want to collect that, so we're not just going to let it float away. We're going to direct it through this tube called a condenser, which will take that gas and condense it back into a liquid. This is a double-walled tube, and we run cooling water through here to cool the gas down and cause it to condense. And then it runs down and we can collect it in here. So here's the higher boiling point liquid, and then what's left behind is the lower boiling point liquid. So taking advantage of differences in boiling points. Filtration. This is a technique that you use in the kitchen a lot. I made some pasta last night for Andrew. You boil the pasta in the water, and you've got cooked pasta and hot water, and how do you separate them? Use a colander, right? Colander is like a bowl with holes in it. You stick that in the sink and you pour the whole thing in there. The liquid runs through the holes and the pasta doesn't. That's filtration, to separate a solid from a liquid. Here, the solid is much smaller particles, and so a colander is not going to work because everything's going to go through the holes. So we might use a piece of filter paper. This is very similar to a coffee filter. You make coffee and you got the coffee grounds and the hot water, and the goodness of the coffee comes out into the hot water, but then you don't want to have those grounds. Nobody likes gritty coffee, right? So you pour it through a piece of paper, a coffee filter. The liquid goes through and the solid does not. So that's filtration.